HC Verma, Wave Motion and Waves on a String, question 14. Here is the setup. A steel wire of length 64 cm is stretched between two fixed supports with a tension of 8 newtons. The wire weighs 5 grams. We need to find the speed of a transverse wave pulse traveling along this wire. Let us visualize a pulse propagating through the wire. Here is the full question. A steel wire of length 64 cm weighs 5 grams. If it is stretched by a force of 8 newtons, what would be the speed of a transverse wave passing on it? The key concept. The speed of a transverse wave on a stretched string is given by wave speed V equals the square root of tension T divided by linear mass density mu. Linear mass density mu is defined as mass per unit length, that is mu equals mass m divided by length L. This formula tells us that higher tension means faster waves, and heavier strings carry slower waves. Now the solution. First, we find linear mass density mu. Mass m is 5 grams, which is 5 times 10 to the power minus 3 kilograms. Length L is 64 centimeters, that is 0.64 meters. So mu equals m over L, equals 5 times 10 to the minus 3 divided by 0.64, giving 7.81 to 5 times 10 to the minus 3 kilograms per meter. Now, wave speed V equals square root of tension T over mu. Substituting, V equals the square root of 8 divided by 7.81 to 5 times 10 to the minus 3. This simplifies to the square root of 1024, which is exactly 32. So the wave speed is 32 meters per second. The correct answer is, the speed of the transverse wave on the steel wire is 32 meters per second. Here are some important tips. Tip 1. Always convert all quantities to SI units before substituting. Grams to kilograms, centimeters to meters. Tip 2. The formula V equals square root of tension T over mu applies only to transverse waves on strings and wires under tension. Tip 3. If you are given total mass and length, first calculate linear mass density mu. Do not confuse mass with mu. Tip 4. Notice that 8 divided by 7.81 to 5 times 10 to the minus 3 gives 1024, which is a perfect square. Recognizing perfect squares saves time in exams. Like and subscribe for more HC Verma solutions at MAGPIEHUB. See you in the next video.